generator, which you don't have to add anything to. I have it's just a file filled with goodies. And then there's the code generator, which is kind of long. You have to write most of that code, I think. Yeah, so that's 1,500 lines. That's good. What do we do? Well, the code generation is hard, but it's probably the most fun one because you actually get code that can run in the real Java virtual machine. So there's a certain amount of pride, satisfaction, happiness, I don't know, it depends on the terms you're on, I guess, about seeing, the 4-queen or the 8-queen problem actually run from output that your compiler created. So your compiler, here it is. Will produce a number of J files, and these are Jasmine assembler. And those you can turn into, you can run them through Jasmine and get out class files that can actually be run on the real virtual machine, real JVM. So before we get that far, we have to go through 3 different visitors. I think I've done one of them. There's generate field inits. There's allocate addresses, and what's the other one called? Generate code. Now let's skip this one for now and talk about the allocate addresses. They frown on me writing on this, right? Oh,
You can type on it.
Just put it up when you're done.
So then get myself in trouble. Let's just so if I have a method that looks something like this, and if I look at the activation record associated with an invocation of one of these, so remember that each invocation has an activation record. What's in the activation record? What is an activation record?
For static language?
For this language?
Isn't it like variable
Oh, it's the return address, the parameters, the local declarations.
It's like what kind of static.
Yeah.
And whatever else is needed, right? You might need a static link in there as well, if you have nested methods. Right. So we don't have to worry about the return address and all that other stuff. You really just have to worry about these guys here. The return address business is taken care of by the virtual machine. We don't even have to program that. But what we have to do is we have to assign addresses within the activation record to locals and params. not super complicated. So the rules are as follows. The first available address is 1 if the method is non-static. And the reason that 0 is not available is because there's it's used for this. So in a non-static method, address 0 in the activation record always contains a reference to this.
What?
And it's a 0 if the method is static. Static methods do not have this reference, so we might as well use address 0. Okay. And in Espresso, there's so this is real Java, and in Espresso, public static void main starts at 1 as well. Any guesses as to why that is? Well, static methods start at 0.
Oh, this is run a static class.
Super?
So is this
Nope.
as a method? Oh, this is static.
That?
Hmm?
Nothing.
What does the Java public static void main look like? It has one argument, string args. That lives at address 0. So if I want this run in the actual real Java virtual machine, I better make room for those there and not use address 0 for my first variable, just in case when you run it, if you pass in some arguments, because there's got to be a place for those to go. So to be on the safe side, we start at 1 for our public static void main. Now, once we have implemented arrays, which I have, I should be able to actually take in command line arguments as well, and it would work. I haven't tried that. So that's just a little things. So if I look at that one over here, then it's a static. No, it's a non-static method. So what address should I give this parameter? 1. So that's address 1. That one? Address 2. This one? Nope. Address 4.
Oh, the bracket. Oh, because
Doubles and long are 64-bit data types. They take up 2 words on the stack. So they take 2 words in the activation record as well, which is why they need 2 addresses. Because the activation record, the stack, everything is 32 bits wide. Right? So this one will be at
5.
6, 5, 7.
6, and the next one will be at 8, right?
Unless there is.
Now, we could be smart about things. Well, actually, let me try something here. I'm going to extend this just ever so slightly. Where did 3 go?
It's part of 2.
Part of 2. Doubles and longs take up 2 rooms. So 3 is not used. What address should I pick for J? 8.
Next one.
There's an 8. Any lower?
Oh, we bid it now?
Yeah.
Oh,
It's the sort of reverse
Five.
auction. You say, how about 5?
because I's gone out of scope.
Because I has gone out of scope, so I can reuse 5. Yes, that's actually correct. That is what the Java compiler would do. And figuring that out is a pain. So
That we probably have to do.
we'll do 8.
Ah, sweet.
No, let's not get carried away now.
Oh, is it?
if we wanted to actually do this with respect to things going in and out of scope, then we'd be much better off assigning addresses, or at least somewhat, in the name resolution phase when I know when things go in and out of scope, because now I've got to do all that analysis one more time. So let's not get crazy. And if you look in local decals and param decals, you will see that they have an address field, and we need to set that. So basically, my allocate addresses is a visitor. Now, which parse-tree node should I implement in that visitor? Well, I should definitely implement visit field decal and visit method decal. Sorry, visit local decal and visit param decal. Visit local decal and param decal. And what do I do in those two? Well, the same thing. I assign an address, and I believe that we're going to use an instance of a generator that holds all the good stuff that we need, and it's going to be housed in a variable called gen. So I can say gen dot address. That gives me the address. And of course, I either then increase by 1 or 2, depending on the type. So what I do is I grab the address that's stored in gen.address, and then I increment it by 1 if it's well, I increment it by 2 if it's a double or long, or else I increment it by 1 so that it's ready for the next thing that needs an address. Okay. So if I have this gen.address, that has to be reset to 0 or 1 once in a while, right? Because when I get into a new method, when I get into a new constructor, if I get into a new static initializer, then this better get set back to either 0 or 1, according to the rules over there. So this is static init, visit method decal, and visit constructor decal. So for this one, set gen.address to what? Well, it's static initializer. It's static context. There's no this field, so we better set this one to 0. Constructor decal always starts at 1. You can't have a static constructor declaration. And what about the method decal? Well, it's either set to 0 or 1. It's set to 0 if it is static, and it's set to 1 if it is not static. Okay. I think that's about it.
So why was it we did increment by 1 or 2? Or that right there is for every single local or param decal we can keep increasing?
Yes.
This.
Okay, yeah.
So imagine you start out with your let me erase this real quick.
No.
I'll put it back.
No. Are you erasing it then?
So I hit the method decal for this guy. I set gen.address to 1 because this is a non-static method, which means that the first available address is 1. So now I hit this param decal here. I grab this value and say, okay, you live at 1. Address 1 for you. And then I increment this 1 by 1, so I get a 2.
Okay, that's why I was thinking that the one that when you're saying like 1 here, I think is that there was 1 going specifically to. I don't know. Okay, that makes sense.
Because this is always a reference, and a reference takes up 1. And all non-static contexts have this. All right, then this guy here gets 2, and increments this to 4. This gets 4, increments this to 5. This gets 5, increments that to 6. This gets 6, increments that to 8. And this gets 8. See, I got the same thing.
So what was that part you were saying about setting it back to 0 or 1 when you're done?
Well, no, not when you're done. Before you start. When you hit a local decal or param decal, you increment, right? When you hit one of these things where you start over,
Okay.
right? Because every method, every constructor decal, every static initializer, when they run, they have an activation record associated with them. Within that activation record, the addresses always start back at 0, right? So if I had another method down here, I wouldn't continue at 9. Because these are relative addresses within the activation record. Okay? Let me just check that we got what we needed here. So we have this is local decal, we have param decal, we have method decal, constructor decal, static initializer, and that's it. Right on. So now that I've gone through and done this, every time I need to deal with a parameter or a local, I know its address and I know its type, right? So that means I can generate the right store and load code for it. So let's take a look at down again. And I actually want to skip the first part of this code generation handout thing. So 621, 622 we'll come back to. So actually let's skip 6.2 and go straight down to 6.3 just to get an idea of what a J file looks like. And while this warms up, let me just produce a J file. So Espresso C, tests, phase 6, Espresso Plus, good tests. There. All right, so when it ran, the reference compiler will create RJ files, just so that you don't overwrite the files that I created, so you have a hard time comparing things. You will create the corresponding J files, so now you can do diffs between RJ and J. So you can see this one here created io.rj, main.rj. Actually, let me show you the code real quick. I don't know if you looked in that ported in here thing, but it's a fair amount of code. This is actually, you can see this is the output of when I run it. So I should get this if I do it right. And I have my little IO class in there. I have main. I have a class for tortoise, a class for hare, and a class for random. So if I look at the list of RJ files, then they're all there. Right. So let's just take a look in main. So it's fairly long, and there are certain rules that guide how these files look. So if I didn't tell you anything about it and you ran the reference compiler, it would probably take you all of 30 minutes to figure out what the rules for how these things would look. But it's let's do it just real quick. So the first line is always .class, and then it has a number of modifiers and the name of the class. And the second line is always a .super, then it contains the name of the super. The first one could also be a .interface if we had any interfaces, and we should also be able to list .implements. So if I have something that this guy implements, then that would follow the super or come before it. Then I list all the fields. I do it in the order fields first and then methods, just because it's a lot easier to read if you have to go find the fields. If they're sort of spread in between, they're sometimes a little complicated to find. But you can see it's dot field starts the initialization of the field, or it's the declaration of the field. Then a number of modifiers, the name, the type, and the initializer if there is one. So sometimes fields can be initialized with equal something, and they can be initialized with equal something if it's a constant. If it's not a constant, then that initializer must happen where? What method? No. When are fields initialized?
When they're declared.
No.
With the class.
No.
I'm sorry, final fields are.
No. So in the virtual machine, when I actually run a class file, when does the initialization of a field happen? In the constructor. So when the object is constructed, if there's an initializer attached to a field decal, that must happen when the object is constructed. So all constructors must make sure to initialize fields that are not constant and that are not static. Why can't I have constructors initialize static fields? Well, because they only get initialized once, not every time you actually create an instance of the object of the class, which means that the initialization of static fields must happen where? What gets run only once?
Static init.
Static initializer. So the initialization of static fields happen in the static initializer. The initialization of non-static fields happen in the constructor, except for when I have fields that can be initialized with a constant, then I'm allowed to put it like that. And of course, what the compiler will do, it'll be smart and just use those numbers because these are final static fields, so in other words, they're just constants. Okay, then I have a number of methods, and they start with the word dot method, and then a number of modifiers, and then, do I have two spaces there? Oh, that's bad. Well, it doesn't matter. And then the name of the method, followed by its signature. And then some magic and a bunch of code and dot end method. And that is the same way you do it for methods, for constructors, and for static initializers. They're all methods. So the magic up there, the first one is really magic because it's always the same. Dot limit stack 50.
You can only have up to 50.
No, this just says the maximum height of the operand stack is 50. How do I know that? I don't. I have no idea what the maximum stack size is. So I figured 50 was a good size.
Oh, you actually said that. I thought it was actually like the compiler.
Well, I'm running the compiler.
Yeah, like somebody else besides us just says it like that and extends it.
Well, so
As needed.
here's how it works. In the Java virtual machine, every activation record actually has a little more associated with it than parameters, locals, return address. They also have an operand stack. So every invocation has its own operand stack. That means that operand stack lives in the activation record. How big should that operand stack be? I can't make it an infinite size. I have to say it is this size because these activation records get stacked on top of each other. So it gets made to whatever size I specify right there. Now, how do I know how big it should be? Well, we'll look at that next week or the week after, because that's really it's not complicated. We just don't have time to go and do that sort of analysis because it requires implementing basic blocks and a whole lot of other.
You can't do it dynamically?
No. Well, there's no point in doing it dynamically because you have to analyze code at runtime. You would analyze the code at compile time because you can certainly do that fairly easily. We'll see how to do it. Because the trick in Java is a statement cannot affect the size of the stack net-wise. So whatever the size of the operand stack was before a statement started, that's going to be the size of it afterwards. So you can't write a statement in Java that leaves stuff on top of the stack. So trying to blow an operand stack at size 50 is actually pretty darn complicated, because you would need a very, very, very large expression that would put 50 things on top of the stack. So 50 was really just sort of like, yeah, that seems reasonable. 10 would probably work just as fine as well. The next one, though, we can do something about. We know exactly how to calculate that one, because it actually is right here. There, gen.address. That is exactly the amount of space that needs to be created in the activation record to hold locals and parameters. Well, that's nifty, so we just grab it from there when we have to generate this code. And then comes all the code, and now we're done. So just go do that, and we're good to go, right? Okay, let's see. So you can see it all looks pretty much the same. I have labels on blank lines. They don't have to be, but it's just easier for us to do it this way.
Isn't that on that? Isn't that about all the spring functions that you had inside the generator class? Generator.
What prints? Huh?
The one you said was full of goodies. Isn't all of these
Oh, well,
structure in there?
let's take a look at that one.
Oh, we actually need to worry about all of this indentation and all this.
No, you do have to worry about the indentation, I'm afraid. But it's 8 spaces.
Okay.
Or no,
Just
it's a tab.
Is
It's
it
a
just
tab.
a
It's a tab. Use a tab because that's what I use. Let's see, code generator. So, what do we have in this generator thing here? Well, so a generator takes in a class decal and a boolean named D. What do you think D stands for? Who knows? Ah, probably some debugging distance here. So when you create a generator based on a class decal. So every time you have to create a new .rj file or .j file in your situation, you create a new generator. And what does this thing do? Well, it actually creates the file name, and see if it says if cd is an interface, then print the interface thing and print some other stuff. And if it's a class, print that out. So it does all that for you. You don't even have to worry about that. Every time you create a new generator based on a class decal, you get the J file started. You get the .interface, the .super, the .class stuff printed out. And then you can see, well, that prints out the interfaces. So it does all that for you. So that header part of the J file you get for free by just creating a new instance of generator. And when you're done, you call gen.close. Sorry, gen.done, just in order to get the output file closed. Okay. So what does it say here? Correction. This should have been set a long time ago. This is way too late to change that now. Do this in the top file. If fd is the number fd not static, print static. Huh. I suppose I fixed that, so.
Did you?
I don't know. Should I leave it there?
Yeah.
They still commented out, I don't think you did. So it's definitely too late now.
Well, that's what it said at the time, right? Let's see if I,
But that was the last.
if something was static, so let's just do a quick search for static. Ah, see? If it's not declared final and static, make it so. Right? So you know what? It's not too late, it's already done. In your face, people. So whenever you hit a field decal, you call gen.define field, and it does all the work for you. I mean, how easy is this? There we go. So when you hit a method decal, you call start method. It does it all for you. Right? And the only thing I should say here is you can see that there's a call to a new visitor there called generate code, and I actually create a new instance of the actual code generator visitor, this guy here. in order to just visit the parameters,